Hello all. It's good to be back. So as mentioned in the previous Docker demo session, that I will make another video on container orchestration. So this is on the same topic. So uh, to be to directly get into the topic, container orchestration is all about making many servers or containers act like one, and the container would say Kubernetes and Docker Swarm are the most popular container orchestration softwares that are available in the market. And Kubernetes being most popular, Docker Swarm, I would say, is a second popular tool, which is by Docker team itself. So Kubernetes is basically an open source orchestration container orchestration software, which is supported by Google. What we do is let's deploy a simple HTTPD server and try to scale it and log into it. We'll try these two, three actions, and then probably we will deploy a WordPress server, and we'll try to scale set it as per the requirement, and how and we will also see how simple it is to scale up and scale down any of these container services. Okay, so kubectl run my Apache an image HTTPD. Okay, so you might notice that kubectl run hyphen generator is equal to deployment is deprecated now. So this run command is deprecated, and we have to start using create. But however, it will be removed in the future versions, and we can see. So if you see someone using kubectl create or kubectl run, that it doesn't make any difference. Both are same. kubectl get pods. Okay, so we have our pod, our container, it is running. So, and I would also like to show you what exactly happens here when we run a kubectl. So, if you look at the resource, though we have deployed only one container, we still see multiple entries when we do a get all. What are these? One is pod, one is service, one is the deployment, and the other is the replica set. So the service, above all, the service is there. This service is the API service which I initially mentioned about. Using this API calls, we interact with the containers, and Kubernetes will also does the orchestration using this service. So this service sits on top of Docker engine, and it does the rest of the things. And then this deployment is the one which we actually did using the kubectl run my Apache. So it does the deployment of the image, and that will create a container, and inside a container there will be a pod. So a container, there can be, and yeah, so a pod, and then I'm sorry. So we did this deployment. The deployment will create a replica set, and a replica set based on the number of replica sets that we have defined. I mean, ideally, the replica set, if nothing is given, it will consider it as only one. That's how you see desired as one and the current as one, and it will deploy one pod, and if the replica sets are more than one, then the same deployment will refer to the replica set entry, whether we have did an exclusive, whether did we mention any exclusive options for replicas, and based on that, it will provision out the containers for us. So the hierarchy is something like this. The deployment creates a resource called replica set. Well, these are all resources which are inside the Kubernetes cluster. So a deployment will create a resource called replica set. A replica set creates a resource called pod, and a pod creates a resource called container. So inside a pod, we will have the container, and we can ideally have multiple containers inside a pod. But now you can find examples on Kubernetes.io on the same. But their best recommended approach is have a one container in each pod, because that way we can keep them loosely coupled, and we can work on the containers as per our need, and if we want to remove any or if we want to add any, that will be done easily rather than having multiple containers in a pod. So as I mentioned earlier, we have one Apache container running, and let's connect into the container. It is kubectl exec hyphen stdin hyphen tty. Sorry, mstty. Yeah, so this is how you will connect into the machine, and you can browse into the files and etc., and you can debug and all. And another part is, let's try to scale the containers as well. We have only one container running, and let's scale them to say three. Kubectl scale. So here, this particular part, right? So I mentioned earlier as well that the commands, they are pretty much flexible in Kubernetes. When I mentioned about service SVC, like it can be used SVC or service in the same time, in the same manner. Here also, we can say deployment space my Apache or deploy slash Apache. It's all same. So right. So kubectl get pods. See, it is creating one all got created seconds ago, and the other is yeah, see. It's so easy to scale based on the need. We would see further on the scaling part when it comes to um, the WordPress and how easy it is to scale. And if this happens in a mass, when the need is when a massive need is there to facilitate the load and everything, how it is going to be, we'll look at through we'll look into it when we come to the WordPress deployment part. Okay, so let's go to the WordPress part. I'm currently removing them. Okay, so I want to show you one more most important feature of the orchestration, and why the orchestrator. I mean, one of the uh, primary uses that orchestrator is all about is, let's say, late. pods. Okay, so the pod got deleted. Right. But let's see. You see, the pod got deleted, but again it got back running. But the time, if you can see, there is a change in time. The earlier the pod was created about 10 minutes ago, and now it is 13 seconds back. So when I delete a pod, it automatically replaces another pod into that. I can show you that with say three. Let's create three replicas. And let's say get pods. Let's give it a few seconds so that all are up and running. Right. So now let's delete one of these pods. Okay. One is two or 14 seconds and one is 68 seconds is what. And pod is pod is deleted. And kubectl get pods. See, there's a new one which just got created, and if you see this, this one, and we have deleted the one which was in middle, but a new pod got appended to the cluster. So that's the beauty of the orchestration, that if we accidentally delete the pod, it automatically creates another pod and replace it and serve our purpose with the number that whatever we have desired for. So this is one of the most important feature which actually helps the many of the systems to sustain any kind of disaster recovery and all, where the auto scaling happens. So in order to delete a pod totally, what we need to do is actually have to delete the total deployment itself. So deployment my hyphen Apache. This deletes all of the deployment. So this, now you may see all the pods getting terminating. Yes. Okay, so this is let's go ahead and deploy WordPress application using Kubernetes, and I'll show you the scaling and I mean the scaling, how just one this is at command line, but when we are going with YAML based scripts, how it all happens, and I'll walk you through that. Okay, let's start by creating our WordPress site, and we'll do that using the YAML and kubectl. So, you know, there are few steps in it, like creating volume and then creating the WordPress and all. So just watch through the steps, and once the deployment is complete, I'll access the WordPress site. Okay, kubectl apply hyphen have. Sorry. then PV, PV, and volume claim. Replica set, and then SQL service. kubectl get pods. So for now, MySQL is running, and then let's log into kubectl exec fanit MySQL. Alright, so here MySQL hyphen u root hyphen p. Have the password. Okay, and now kubectl get pv. Let's go ahead with WordPress setup anyway. I mean, MySQL wouldn't be up if those all are not successfully created because I have to finish off this session as soon as possible as well. So we'll apply -f WordPress. Right, so next kubectl apply -f WordPress deployment. And but since there are two ports now, we have to have, because I said this example is mainly about showing the replica sets. We should have a load balance as well, load balancer as well. So right now I'm going to load balancer. Right. So now we can observe why what are the services that are created. This the commands specifically in Kubernetes are there are short and long forms like for kubectl. So get svc also gives the also lists the services. So it is svc services and svc. Don't get confused if you have a get it. So as you can see, I have mapped it to a local host. So now let's LocalHost. Sorry, it is this is still in history, I guess, from the first session. Yeah. So this is what it is about. Continue, and it's the same how we created and all. So the one of the primary thing which I wanted to share is like if you see. So now kubectl get pods. We have only one pod for each application is running. For MySQL, say SQL, there is one, and for WordPress. So imagine this is a production scenario, and we have huge requests coming in. So to gather all those requests, all those requests, I need the WordPress to take enough load. So what I would just do is uh, I would open it. So here the replicas, I'll make it 5 and will save it. And I don't even have to restart. I just have to apply it. kubectl apply hyphen f WordPress deployment. Right. So kubectl get pods. See. See, I mean, it literally took only less than 10 seconds to bring up multiple nodes. I mean, just all about. I hope I might have given you a good insight and good insight. And thanks. I thank Professor for giving me the opportunity, and I thank you all for. I mean, it's been a pleasure for me to share the knowledge. Thank you.